Are we live? Are we? Maybe we are live. If YouTube would load. We are indeed live. Hello, hello, hello. Test, test, test. Okay, we are live. Hello, people. Hello, hello, hello. Oh, I got a notification that I'm live. Okay. Just check something. Yeah, that's that. Hello. So, as the title says, oh wait, I have to do something else first. Anyways, as the title says, we are going to be creating games that run on your desktop wallpaper. Stupid, I can't remember. Anyways, so this is my normal wallpaper. I have some code here that I was building before to find out the how to draw to the wallpaper, and I can do that using OpenGL. So if I click run, you're going to see a video is flowing on the what it's called on the wallpaper, and then it's reset back to just a second. Okay, so as I was saying, so if I click run with debugger, and it runs the video that it takes. It's 20 hours. So what the video is shown. So we use what is it, OpenCV to read the video frames. Then we go and render those frames using OpenGL. We do the normal bits. We clear the color. We bind the texture. We set the texture to the OpenGL shaders. We set it to active. We bind the texture. Okay. Why do we bind the texture to that? I'm not sure. Anyways, we draw the one triangle that is this to this, this to this, and this to this, and the other triangles, and then we draw them and put the image there. And then we swap buffers. And then we free frame and frame it because we can see new video frame for whatever reason. I don't know how you're using new video frame. So it's easier to pass around because So this is why do we swap buffers? That's so you don't I don't know if you have to clear color, but it's just what happens between the image I guess to reset the image. That's why it's of course. And clear color. And why we swap buffer is because when you are using graphics cards, you have two images. One image is the thing that's rendered to the screen, and the other image is the work in progress one. So you do all the work on your work in progress one. Then after you're done, you swap the image. So the user doesn't get half of a finished frame. It gets the full frame, and then you can restart your work on the other frame. And that's why we swap buffers. Why we are passing frame as a pointer is because these are two different threads. One thread is the main thread, which does all the drawing, and the other one is reading this video task. It reads the video and waits for the time and stuff like that. Frame number. Anyways, it copies this frame into there, and then it sends us. I have to show my girlfriend the bunny video one more time because she finds it very funny. Anyways, I just noticed I can maybe move the unlock here. Or wait, when do we lock? Okay, this makes sense. I guess we can move it like here and there, and doesn't really matter. Anyways, so this is just a proof of concept. Why we are using what it's called. So we can not use glfw, which is what's normally used to create windows, so you can display your things, your OpenGL2. What we have to use is normal Windows code to get our thingy, to get our so we can get our desktop background. So we can go here. This we set up. Okay. So we set up all of our OpenView code here. Below the so this is the background. Okay. Here is how we reset the wallpaper. We get the wallpaper path from the system parameters info, which is I think the registry for Windows. Use SPI get desk wallpaper, and we get the path pointer, and we get the info, and then we set it again, which updates the thing. I don't know why. I mean, I understand why. So anyways, next thing. So we use okay, so let's start from the main thing. I have not touched this project for a long time, so I don't know where everything is in applications. So we have perfect. So Windows uses HWMD. So I don't know how you say it. It's a pointer. That's what it is. And like mostly a pointer. So it's a pointer more or less. So how we get the Windows, the wallpaper window is we find the program. I don't know what that means. Then with that a program, not a program, program. So we fetch. Okay, so this is copy pasted from some Stack Overflow question probably, because I don't know how else I would find this out. So we fetch the program window. We send this to the program. We send this message direct program to spawn a worker W behind the desktop icons. If it's already there, nothing happens. Then we enumerate all windows until we find one that has a curl DLL def view as a child. If we found that window, we take it as its next sibling and assign it to work. So in enumerate windows, we find someone that's a window that's called shell DLL whatever. Then we use, if it exists, if we can find it, we set the return to worker W. So I guess it's child sibling. I'm not sure, whatever it says here. It's next sibling, and that's how we get our HW and ND pointer. I don't know how this works. It's explained here. I still don't understand any of it. It does work, so that's good. Next. Then we also need to get DC. Okay, let's do this. Get DC. Functions device context. Okay, so DC is device context. What's a handle? So okay, so this is a handle to a window. So H means a handle, and when a WND means window. DC is device context, which is used. You can use it there. So we can call VDI functions and stuff like that, which that means we can render to it. Most something like that. And after we get the handle, then we get the device context, and then we run OpenGL here using the handle. So we set the handle. I don't know. We don't set it up there. I'm not really sure. Then what we do is we set this pixel format scriptor. It's not my fault. It's all one word. Pixel format descriptor. Anyways, so we set it here. Then we get the device context. We already got here, so I don't know why we get it again. But anyways, we get the device context. Then we use the what is it? Pixel format. I don't know why we don't just do this. It does work. I think it does work. Huh? Yes. So using the device context, which is DC, and PFD, we get. Let's go. I hate this. This is why we use this. Because you will not understand these functions without MSN. Is it MSN? Whatever this is. So function attempts to match an appropriate pixel format supported by device context to given pixel agency PPFD pointer to the pixel format descriptor. In that return value of the function sustained, the return value is self-format indexed, one based, that is closest match to the given pixel format is fails, the return value is 0. Okay, interesting. So then we set the pixel format. using this, with this, and this. Then we open GL random context. We create a context using WGL create context, which is I think Windows GL context. Yeah, so I guess W means Windows. Probably Win32 something like that. Then we say make current, which is make context current. We get the device context and the rendering context, which is usually done with the GLFW make context current, which does this with the window. We do that here. GLFW init does this, and make context current does this, and we do it all at the same time. And then we load the head. When we delete context, and that's about that. I don't know why we have this, or why it's not done like this. Like, I don't understand many things, including these ones, I guess. Let's see. So I don't need this. Or do I need this? Also, DC, I'm sure is not a hardcore function, but I don't want to call it multiple times. So it's gonna be HDC. See, where's device context? Window device context, which it will be here, and then we go to the OpenGL implementation, and then into the menu. So open takes this, and also this, and we just set the srand time null, which creates a random in the quotation marks thing. Mute. So okay, when we delete the application, I guess get the mutex, lock it, swap it, which I think is like a delete, unlock it, and then clear all the monitors. Very fun. Because we are in the window thing, we cannot use normal. This is nice. Okay, I don't think this actually. So since we are in Windows, we cannot use the normal config, which means we have to allocate it ourselves. Here is the allocated one. I would not suggest using a console because it's usually just pauses the execution of everything, which is not nice. Press any key to execute. So it does work, as you can see. We press the button, we move this, and it works. And the console says just before and after. So the rectangle size, because I have 3 monitors, it's this monitor. So how much I have to go, and where's the yeah, that I guess I didn't show that. If you go here, I have to get all the monitors we have. Which we do with Windows API, because again I guess we can use GLFW for some things, but I would rather not, because it would very much break something. I'm not willing to spend time to unbreak it. So we get the window cracked, which gets the whole size of all the screens. So, and it's also, I guess, dependent on the position of the screens. So my 3 screens are like this. So there's, how do I show off screen? So this is one, then the other, then the third one. And so it's like 1920 height and no, 1920, so 1080 height and then whatever is 1920 times 3. Later, which I think we saw, 5760. And then so we print rectangles, as you can see here. This is our rectangle. And so it's before, rectangle 0, 0, 5, 7, 6, 0, 1080. And up of 0, 0, 5, 6, 7. Normalize rectangle. Why we normalize it? Because I guess it can go into a minus. Because if this is a main screen, so I have 3 screens. The middle one is is the one you see and the one I'm looking at. And then I have one to the left of it and one to the right of it. Since if it was the main screen, it would go from minus 1920 to just times 2. Okay. 1920 times 2. It will go to 3840. And here, so it would be minus 1920, 0. Instead of 5760, it would be 3840. 3840 and 1080. Perfect. And now it's only this normal because the left screen is the main one. Correct. So we enumerate the monitor using the desktop DC. So the device handle for the desktop window size, which is this, which is the rectangle. So all the monitors inside the rectangle. I don't know what this data is, but I know this is the function we use. Enumerate monitors. If the monitor, I guess, if there's no monitor, we just print out no monitor. Then we get the device handle, the rectangle, and the data. Then we get monitor info. And then we get the monitor info using the get monitor info. I guess this is a define, yes, wide. H monitor and RP monitor info in RPMI. Monitors we put back. So hit the monitor, rectangle, so the rect, and the actual workable, I guess, size of the monitor. I don't know what the difference is exactly. I don't really care. Minus left and max, minus left and max, minus top. So we use this so we can move all the monitors to all positive values. So it's much easier for us to actually set them up. What I mean by that is to get to them, because it doesn't, I think, go from minus, it just actually works normal. I think at least. I'm not really sure. Anyways, let's see. Yes. So that's how we get monitors. If it's empty, we set monitor. Then we set the viewport to one of these monitors. If it's 0, it's the middle one for me. If it's 1, it's the left one. If it's 2, it's the right one. Perfect. So area, and what's the thing? Working area. I guess if I say set it to working area, it doesn't do the unseen. It doesn't do it below, I think. So it doesn't do it below this, below taskbar. It does do it, but it should just be pushed up, I think, a bit, which makes sense. Let's reset it because I need to do this and wait for it to finish and then close it with this, so we reset the wallpaper like we said. So it's using this, so we get the info and we set it back. So our job, I guess my job, is to build a game, like we said before, which we wanted to be first game, because it's the easiest one, is going to be I cannot remember the name. Flappy Birds, like Flappy Bird. Not birds, one bird. Flappy Bird. Uh, with that, so we will try to build it. I've never built any kind of fully featured game. I don't think. I worked a bit in Unity, and I have done a lot of work with LWJGL, but this is C++ and not Java, so I guess I'm kinda effed. So I want to rework all of this. I like how this looks. I just don't want it here. So we are going to. Okay, we need to change all the namespaces. So it's not. I guess so. So it's wallpaper API. That sounds like a nice name. Wallpaper API. Anyways, nice name for an API of wallpaper. If anyone has better ideas, please do tell them. But yeah, we are going to redo more of these things. So let's start from the application.h. Quit message binder. This is used everywhere. And by everywhere, I mean like graphics. If you go into graphics and then video task, we send the event type with. Why are we actually using this everywhere? Anywhere. H. I don't think we are. Let's open. Find all. Oh, so it's not used that. Oh, that's nice. We don't need this. We have the application. We do we need post events? That's not how we're gonna look. Just a second. So we're gonna try to do an event manager, I guess. And see how that goes. Second is tab. This four spaces. I hate that this line is not correct. I haven't streamed in like, what is this? 11 days. So it's really hard for me to talk this much. And I also have a big ass bottle of water that I'm drinking because my mouth gets dry. I clickbaited myself because I saw this report that they posted and it says watch live. I'm like, oh, I have 35 views, and they were like, wait, doesn't get views the live stream actually. Average view duration 28 minutes. I mean, that's not bad. Anyways, at least I'm like myself. Excuse me. So I want to move all of this to another part of the code, so it's not in the application. The application is gonna have a window manager, I guess, in quotation marks, a renderer, and all of the layers. This is gonna be like a game engine, but very bad. Like really bad. But we are going to try. So. Hmm. Where do I move this? Yeah, I need to use static things, but it is what it is. Let's see. Or hmm, let's see, new item plus window manager. Window screen window manager. I guess it's a window desktop manager. Monitor manager? Maybe a monitor manager. Sounds better. Monitor manager. It's okay, and that's gonna be outside of everything. I need to move it here. So we are going to move application.h. We're going to move this. Okay, let's go. Okay, like this. Perfect. What happened? Okay, so remove that. Get monitors. Enumerate monitors. Okay, we don't need this anymore, I guess then. Then we need this. And we don't need events. So we only need the monitor one. Don't need the mutex monitor. What's a monitor? So it's in here. Include, yeah, monitor.h, monitor manager, perfect. Ah. So what we want is name space. What's the namespace going to be called? Wallpaper API? I guess, I don't know. I'm going to try to stick to CPP conventions. I cannot promise anything because I hate it. I'm going to do my best. Oh no, it's okay. Okay. And then we need monitor manager, I guess. Does our renderer hold this? Or what holds this? Because as far as I know, because I think this needs, like, if we go into the application CPP, monitors, get monitors. Yes, let's do this here and field of size. So we're going to have something like public get monitors, which is going to return this, something like this, I guess. This. Yeah, like this, because we are trying to keep up with the convention. Yes. I don't understand myself sometimes. Enumerate monitors, yes. Let's get this from there. Monitor. Perfect house. Oh, fuck, that's so slow. Stick wall, okay. We don't need this, not this. Perfect, so get monitors. If as monitor empty. So if it's empty, we will try. Hmm. So maybe one constructor. I think that's this. What do we want from it? Well, most of what this is. Something like the wait, I like fetch monitor because that's what it's doing. I think. I guess I would call it fetch monitors. Not create monitors. Create monitors doesn't make much sense. Fetch makes because get monitors is already taken by forgetting the monitors. So we don't want maybe not empty one. Maybe we will do this up here. So we need the desktop HWND that is stop. Maybe handle, and I need to remember handle. That's monitors. I think this is a reference. I think, which means it shouldn't make a problem. I hope. And we need a desktop, which is something. HDC, which is the device context, desktop device context. So here. So get this private. See this WMD and HWND handle and device context. So HW command. So handle and device context. Perfect. Let's see. We don't really care, I think. We are gonna normalize them. We don't care about the other things. If we go to utils, we don't want enum Windows Pro. Enumerate Windows Pro procedure. We're gonna leave it there. Wallpaper, yeah. This needs just dot slash utils page that. And it should work. Okay. Oh, excuse me. Utils page. Like that. Like real C programs. this generates our date. Maybe something like optional would be better. I don't think so. Yeah, no need to that. You get a reference to it. I think that's how you do the references. Let's see. Return reference. C++. Yeah, that's that. Okay, I was correct as always. Supplies many wow. Let's we get the size angle. Okay, so we also want to do something like we just want for header, not header. So we're gonna define log in the shout. Perfect. And then we're gonna do this. Why I'm changing this is because, okay, so when you are using, so we want to be able to have logs for ourselves, but we don't want uh, people who actually use these games, if anyone would actually use them, to actually be able to see the logs or even have the logs enabled for information. Maybe if it crashes or something like that, we want the users to be able to send us the log, but we don't want them to have the info log like this. I'm sure they don't care that one of their monitors didn't show up. Maybe they do. I'm not sure. I don't think I care either way. Let's see. Or the works. Who was thought? Who would thought? Get this as I think normal. That. Why would that not work? I like this. This actually looks better, in my honest opinion. So I'm just gonna copy paste it. Like this, perfect. Monitors we don't need this. Perfect. I don't care. I'm not even gonna try to compile because it's gonna go back. Echo. Let's see. So, what does our application need? Well, did I not remove the monitor? So I don't understand. All right, we need. Wait, what? Yes. Why do we need it?